Welcome back. Today we are going to start a new software called STAAD.Pro. We can learn about this software. This is an analysis software which we can use for analyzing different structures by applying possible loads acting on it. And finally, based on the results, we can modify or redesign the structure based on the load. If the load fails, if the structure fails based on the load we are applying, we can change the design. The basic modules in the softwares are modeling, analysis, and design. In this current, we have to do the model using different tools. There are so many tools are there. When you open a project, we can see what are the tools available in the project, available in the software, and after that we can learn one by one. Now, when we open the software, you can get a window like this. This is different options when you open the software, new open project, and different options are there. Now we will go with this new project. We will go with from the beginning. New project. If you click new project, you can get a window like this. Here we have options: keys, plain, pro, plus, etc. Now this is the beginning, so we will go with this option, and you can give basic tutorial 1 here at the master title. And here these are the two parameters here, length and force. This we need to change here because this is the English units, foot and kilo-pound. We will go with the meter and kilonewton. For we will change to meter, and for force we will change to kilonewton. So this is the basic we have to do in the beginning. And click next, and here you have some options. You can go with add. So here I am going to do a simple beam only to get an idea what is this software. We'll learn more about the software in the next tutorial. Just I want you to understand about how the software works, the use of the software, what is the features, something like that. Only we will learn this much things. And if you are interested, you can comment on the video regarding more about the software. Then I will explain more about the software. Now we will go with and finish. Now you will get when you open, you will get sitting like this. Here you can see some grid lines, and you can edit this grid line by clicking edit option here. And you have in the x direction, you have the axis here, x direction, y direction, and z direction. Now we have to edit this x and y direction. If you want to edit this grid line, you have in the x direction you have 10 grids, and in y direction you have 10 grids. So you can edit by changing this value. I am keeping 5 on x direction and 5 on y direction. The spacing you have 0.3, something like that. I will keep 1 meter here. So accordingly it will change there. Okay. And okay, this is the grid line settings. CC and here after that you have to. There are so many options you can see. This one today I am not going to explain every tools. Just I am giving a quick example. What is we are planning to do in the software, and what is the benefit of the software, what are the application, something like that. If you are interested to learn the software, then you can talk to more tools and features of the software. I am just explaining only the basic tools now. Now this is in the isometric. See, this is in the isometric view. You can change the view by clicking any options here, or if for front view you can click here, and for side view you can click here, and top view you can click here. I am going to do the front view. and here you can see the add beam option is there. If you want to enter a plate, you can use this one. You can, and some options are there. Mainly we'll go with the beam, and now today I will go on about beam only. And here these are the selection options for selecting nodes and selecting beams and plate. Different cursors option is there. Now I want to start a node. The main use of node is we need to apply the load only on the node only we can apply, or in the point load or something if you want to apply, then you have to use node. Node is must for every structure we are going to model in the software. If you want to draw a beam, you need a node between two beams. So we have to do a node. We have to create a node here. So you can see the node window is there. You can apply here. XY is the direction. You have to mention in which point it is going to place. So the first node, you can see here. First node I am going to give 0. Node direction is direction, Y direction is the direction. So one point is created here. You can see a small point is created here. You can select this node cursor for selecting the node. You can see that point is unselected here. And you can here, if you want to enter the second node, you can come here and you can enter the first value. I want in X direction I want 1 meter, in the positive X direction 1 meter, and in Y direction 0, and Z direction also 0. So you can see one more point is created, node is created. If you want to move in Y direction the node, then you can click here from this 1 meter. At X direction how much distance you want, you can enter here. Positive X direction I am keeping 1 here, 1 meter, and in Y direction you can enter how much height you want. In the Y direction you can mention here. So if it is 1, then you can click here 1. So one more point is created here. Z will keep 0 now, and this is how you have to make node. And I am going to usually do this two node now. You can see 2 nodes. Now based using these nodes we can create a beam. You can come to this beam option, add beam option, click this beam tool, and you can connect the beam by using these nodes. Click in the first point and second point. So now the beam is selected. You can select this cursor and you can select the beam. You can see now the beam is done. Now the second thing we have to do, after first thing we have to make a node. After that you can create a beam, and third thing you have to do, you have to go to general. You have so many options here. Setup, this is the basic modeling option. After that you can see the geometry. Here you can enter geometry where you are doing all the structure modeling. And now I am doing only one beam. In the next tutorial you will learn about more big structures. Now I have done with the geometry. Now the next option is general, where you will apply the defined beams. That is, we will define the material. What material? This beam. This is now just a beam. There is no. We didn't define anything. We have to apply a profile on this beam. Then only we can apply the load, and then we will get the result. So here you can see in the general option property, where you have to apply the profile for the geometry. So here you can see define section database. If you go to section database, you can see different profiles are there for American and Australian, Indian. You can see the different profiles available in different countries. Now you can. Now I'm going with. I'm not using this one. I'm using symbol beam. So I will define it. You can define option is there. You can define the Now we have to define this beam. For that you have to go for the define option, and for that one here I am going to get a rectangle option. So we have different options like circle, rectangle, T, possible different profiles are there. I am going to the rectangle option. You can enter the value, this width and thickness. For width it is D, so I am going to give the unit is in meter, so you have to enter the value accordingly. I am going to give 0.20 mm thickness, and I'm going to give y direction. Width is going to be 0.05, so 50 mm sorry 50 mm width. So, and after that I can change the value. Here the material, what material required, you can enter here. In the STAAD.Pro you have 4 different options. Different materials are there as additional value: steel, stainless steel, aluminum and concrete. Apart from this you can add any other material like glass, wood or any other material, fiber, whatever you want you can add. But for that one you have separate option is there for defining material. Only all you have to do, you have to enter the values, different values, Young's modulus, Poisson ratio, and different parameters you will have to enter separately. So now we are going to learn about whatever default is there. I'm going with the steel option. Click add. You can see whatever you entered will come here. Now you can use this file for defining this one, this beam, and for that one click and assign to selected beam. Fine. Now you can see the beam is changed to the corresponding profile what we have defined. You can see thickness 0.02 mm. The width is 0.05. Okay. So if you want to see its 3D view, then click this option how the object is looking like. See, this is what the object we have defined. So now we'll that is finished. That part is finished, defining part. Now we have to go for supporting. Support option, there is no support currently. There is no support. You can create a support by clicking this create option. You can see different supporting options here: fixed support, pinned support, cut and post, and so many options here for support. Now we will go with this fixed support. Fixed support, all the in all direction this is fixed, and it will not allow any rotation. So click add, and you can apply the support to the node we have. Click use cursor to assign, and click assign for this node and this node. So both ends we have supported, both end of the beam we have supported. Now it's like a simply supported beam. And now the support directions also done. Now we can go for load and definition. Before that I want to split this beam, since I want to add a point load at the center. So I want to option, and the distance of 0.5, 1 meter is our beam length. The 0.5 distance I want to add one more node, add a new point, and click OK. Now one more, to select node cursor, you can see one more node is created. So now we have 2 beam, and here we can give the load and definition, load case definition, load case details. For that one you can click on load case, click add, and first initially we need to, for primary load we have to consider dead load first. Here you can enter dead load and click add. I want to add live load. For that you can click live load and enter here live load. You can add and close. For dead load is nothing but the self weight of the body. So you can add dead load. click here add, and you can see the sulfate along y direction. This is the y direction. When the red sulfate will always act downwards because of gravity. So you can add y direction, click y direction, and click add. So sulfate is here, added here. And now live load, we need to assign the live load, define live load. For that, click this live load option and add, and you can come to this member load option of uniform force. I want to apply uniform distributed load of value here along y direction. So downward direction, so I want to keep minus 25 kilonewton per meter along y direction. So click add, and see that load is being created. And I want to add one more live load, so that I want to add click live load to add close to live load 1. Here I want to define this live load to add, and same member load I'm going to apply a concentrated load. Here also 0.5 per 10 kilonewton along y direction. If it is minus, since it is acting downward direction. That so we can assign each values, load values on this beam. And assign to you whatever the available in the do, it will assign the sulfate, because now is sulfate is being added, and you don't need if you want to distribute load I want to add. For that you want to click this option and assign to selected to surface sector line, assign this beam and this beam 25 kilonewton, and the next load I want to concentrated load at the center of the beam, each beam. For that I want to assign this beam, this point load at the center. So this loading option is done. Now we can go to analyzing. Before that I want to add the values, all possible values I want to come under it. So I want to add this all option and click add, close. Now we can go for analyzing. So this report analyzing is now. So there is no errors. So we can go to post processing mode. So then we can see the display. Click apply OK. See the summary here. Now we can see at point mode number 3 you have a deflection of 0.8 mm. That is, at this point you have see the deflection. See how the beam is moving because of the load. This is the displacement summary deflection value 9.8.6. If you want to see the reaction, we can come here at the reaction point. The maximum reaction is at point in Z direction is 1.875 at both supports. This is the reaction. And for stress value you can come to beam and you can see the stress value of the beam. See how the bending moment, bending force, shear force on the point, different points, and the stress values you can get from here. Maximum stress. Maximum stress value. Maximum stress is live load for the live load 1 and live load 2. 1.3 is this much value. So you can get from here the stress values. Compressive and tension. You can understand the graphs if you want. You can see the graph how this load is acting, and the animation if you want to see the deflection how it is moving. See the because of load how the beam is bending. You can get the animation from this here. This one in summary, everything you will get from here. Now this structure is safe. It is not it's not failing because 9 mm is a small deflection. It's not that big a deflection, so structure is safe. And what profile we have used is 20 mm, 20 thick and 50 mm wide. Flat bar we have used and as a beam, and when we applied the load we are getting a deflection of this much, maximum deflection at the center point. There is no support at that, so only we are giving support on both sides. So this is safe. You can change the value here, and if you want to change the value here, you can change it again. If you want to come, you can and you can value. If you give more value, then the deflection value will be very high. So for this much force, the beam is safe. That's what we have obtained from this analyzing. I hope this is enough for this today and for today class. For this tutorial, we will learn more about the different structures. And so now we have designed only a simple beam and applied some load and we have learned how the result is coming, what are the displacement, how much displacement is there, reaction and stresses, and we have learned all those things. When we do a big structure, we can learn about more things. I hope in this tutorial we can see different things, and we will learn more about the different tools also. Kindly give the comments on the, so then I can model and design the structure.